This podcast is to show you how to do hypothesis test for the population variance sigma square. Now, the null hypothesis H0 can be sigma square less than equal to Q. Q is specified. Or sigma square equal Q, or sigma square greater than equal to Q. Then alternative hypothesis HA will be sigma square greater than Q if H0 is sigma square less than equal to Q. Now HA will be sigma square not equal to Q if H0 is sigma square equal to Q. Now, when you have not equal to, then we have two-tailed test. Now, HA will be sigma square less than Q and with left tail test if HO is sigma square greater than equal to Q. Now, the next one, we calculate test statistic. Test statistic here with chi-square. Now chi-square equal, be careful, n minus 1 times s square over q square. S square is sample variance. N is sample size. Now be careful when you use a calculator or you use Excel. When type this number is not easy. You need to be very careful for your parentheses. And finally, we need to calculate critical value. If we have right tail test, we use chi-square right, because chi-square distribution is not a symmetrical distribution. So chi-square right in Excel equal CHIIMV, and then you put probability alpha. Now, if we have two-tail test, then we need to calculate both chi-square right and chi-square left. Now, chi-square right is CHIIMV. Inside parentheses, you put alpha over 2. And chi-square right, chi-square left, we use CHIIMV. In parentheses, you input 1 minus alpha over 2. Now, if we have left tail test, then critical value chi-square left is CHIIMV. Inside parentheses, you put 1 minus alpha. So, if test statistic chi-square greater than chi-square right, we reject H0 when we have right tail test. When we have two-tail test and test statistic chi-square greater than chi-square right or chi-square less than chi-square left, then we reject H0. When we have left tail test, if chi-square less than chi-square left, then we reject H0. So this is a principle. Now let's see the examples. So the examples with individual lines at the various windows. The Jefferson Valley Bank found that the standard deviation of normal distributed waiting line on Friday afternoon is 6.2 minutes. The bank experimented with a single main waiting line and found that for a random sample of 25 customers, the waiting time had a standard deviation 3.8 minutes. Based on the previous study, we can assume the waiting lines are normally distributed. At 0.05 significant label, test the claim that single line causes lower variation among the waiting time. Now remember, low variation means standard deviation is smaller or variance is smaller. Now, when we read the questions, 6.2, this 6.2 is from previous experience. So the 6.2 is close to population standard deviation. So when we put our null hypothesis, we put sigma standard deviation greater than equal to 6.2. And then this 3.8 is come from experiment. So this is sample standard deviation, or we say this is S. Small s is 3.8. Now sample of 25 customers, so 25 is your sample size, so n equal 25, and alpha is 0.05. So now we can set up our hypothesis test for the variance. Now it doesn't matter you test population variance or population standard deviation, they're all the same. Now here we test standard deviation. So H0 is population standard deviation greater than equal to 6.2. HA is standard deviation less than 6.2. So this is left tail test. So we need to calculate chi-square left for the critical value. Now test statistic chi-square equal, remember, n minus 1, so 25 minus 1, times s squared, that's 3.8 squared, divided by q squared, q is 6.2 squared. So put this in calculator, you will get 9.0156. Now critical value, we want to calculate chi-square left. So we use Excel function equal CHI-INV. You put 1 minus alpha and comma degree of freedom. Chi-square distribution follow according to degree of freedom. So you get comma 24. So you will get 13.848. So now we can say compare chi-square. Chi-square test statistic chi-square is 9.015, and then critical value is 13.84. So we know test statistic less than critical value. So we reject H0, and then conclude the single waiting line causes lower variations.